Your Royal Highness, Excellencies, ladies and gentlemen, I now ask your attention for a message from the site from which Marconi sent his historical first signal across the Atlantic.
This is Goonhilly Down, Cornwall, up on the jutting headland known as the Lizard Peninsula, the most southerly point of the British Isles. And this is a place of history, not only the great maritime ventures of Britain down the centuries, so often linked with the equally proud seafaring traditions of the Netherlands and her people, but history of recent time and modern technology. For it was from here that the first transatlantic communication link by satellite was forged on the night of July the 10th to 11th, 1962. My name is Raymond Baxter. I was the BBC television commentator down here to cover those exciting events 20 years ago. So if for that reason alone, because I can claim to have been the first broadcaster ever to have addressed the American television audience at home by satellite, may I say at once how very pleased and flattered I am to be able to join by television the distinguished audience in The Hague at this moment, and to join you on behalf of all my fellow broadcasters in honoring the man whose foresight and technical ability have made such a remarkable contribution to the miracle of modern telecommunications, which today we all take so very much for granted. The fact that he was born not many miles from here across that horizon at Minehead in Somerset enables me to claim him as a fellow countryman, as well as a fellow writer and reporter in science and technology. And incidentally, we both served in the Royal Air Force. But there, what I may have in common with this great man ends, for as I may claim to be a reasonably competent hack broadcaster, his name towers with the great men of our time, rightly honored throughout the world, as he is today by you, Your Royal Highness, in this ceremony at The Hague. And of all his remarkable body of work, it is this which brings us to Goonhilly today. It's a copy of the magazine Wireless World, dated October 1945, headed Extraterrestrial Relays: Can Rocket Stations Give Worldwide Radio Coverage, by Arthur C Clarke. And this, remember, was written in 1945. Let me read from it to you. It will be possible, he writes, in a few more years to build radio-controlled rockets which can be steered into orbits beyond the limits of the atmosphere and left to broadcast scientific information back to Earth. A little later, manned rockets will be able to make similar flights with sufficient excess power to break the orbit and return to Earth, a clear prophecy of the space shuttle. But later in the same article, it will be observed that one orbit with a radius of 42,000 kilometers has a period of exactly 24 hours. A body in such an orbit would revolve with the Earth and would thus be stationary above the same spot on the planet. It would remain fixed in the sky of a whole hemisphere, and unlike all other heavenly bodies, would neither rise nor set. A body in a smaller orbit would revolve more quickly than the Earth, and so would rise in the west, and indeed happens with the inner moon of Mars. Now that night in July 1962, Telstar rose above that western horizon, was located and tracked by the dish aerial, the strange new addition to this ancient landscape, and the Atlantic was spanned by live television. 3 years later, just 20 years after his prophecy, Earlybird went into geostationary orbit precisely as he had predicted. I quote again from that original Wireless World article. Many may consider the solution proposed in this discussion too far-fetched to be taken very seriously. Such an attitude is unreasonable. Now, this was not the fanciful writing of space fiction. This was a technically argued scientific proposal. And that it was made to happen from here was no random chance. It was, again, the product of a carefully made scientific judgment based upon past experience. For a few miles away from here at Poldhu in 1901, the very first radio signal had been transmitted by the man whose name became synonymous with radio communication across the Atlantic and around the world, Marconi. He too was a visionary, but like Arthur Clarke, his vision was backed by that other quality inseparable from greatness, technical ability and understanding. What more fitting than that the names of Marconi and Clarke should be linked in this ceremony today. And so now, from this corner of the British countryside, which was the setting for their joint triumphs, we honor those two great names, Marconi and Clarke. And is it too much to hope that we lesser mortals may yet be sufficiently enlightened to profit from their genius, and so to employ it, that the world may yet become a better place for the family of man to live together in peace?
I call upon Dr. Walter O. Roberts to read the citation for the recipient of the Young Scientist Award, Mr. Willems. Mrs. Marconi Braga will present the award. So.
I must just digress for a moment at the outset, after that wonderful demonstration of telecommunications, to say a couple of words to you, Arthur. Those of us who know your 2001 A Space Odyssey, and of course we number in the millions, we await with very great excitement your forthcoming 2010 Space Odyssey 2, which is coming out this November. There are two other things that we await with interest. One is the success, for which we have the highest expectations, of the new Arthur C Clarke Third World Communications Center, and we hope 2 years from now you will tell us about that in your address before the Marconi International Fellowship celebration. But finally, we await with great anticipation to know the outcome of your forthcoming ping pong match with Carl Sagan. And there's a big story behind that. It is now my great pleasure to read the laudatio of Mr. Franz Willems, third recipient of the Marconi International Fellowship Young Scientist Award, presented through the generosity of the Herman Goldman Foundation and through the auspices of the Marconi Fellowship, to a young scientist whose age, as Joya said, in the year of selection, does not exceed the age of Guglielmo Marconi when he completed his first transatlantic radio message in 1901 at the age of 27. The award is given annually to a young scientist from the host country of the award ceremony. And it is for a young scientist or engineer who exhibits promise of a productive career in application of communications for the benefit of mankind. The citation follows. Franciscus Maria Johannes Willems, already at your young age, You have done outstanding research in information theory and in communications theory. Your contributions hold promise in the minds of your colleagues of leading to a general theory of information flow in networks. It will be exciting if a coherent theory of such informational flow is attained. It will have implications as far-reaching and practical as the analogous existing theories of electrical network flow and of fluid flow in pipelines. The importance of such a theory is heightened, I believe, by the world-encompassing information revolution that is now in progress, and to which our attention was so eloquently called by a previous Marconi Fellowship recipient, the late Colin Cherry, whose widow is with us here today. You have authored or co-authored several major technical papers about multiple access information channels and have been a respected participant already at your early age in 7 important international symposia in this field. Your work exhibits scholarship, great mathematical skills, and indeed shows brilliant promise for a career of both fundamental and theoretical importance as well as practical significance. These accomplishments eminently qualify you to receive now the Marconi International Fellowship Young Scientist Award, which will be presented to you by Mrs. Marconi Braga.
Royal Highness, members of the Marconi International Fellowship Council, members of the Dutch Selection Committee, distinguished guests, it is with profound gratitude that I have just received the Marconi Young Scientist Award 1982. This day will remain a memorable day, and it is an honor to receive such an award in such eminent company and in such magnificent surroundings. Be assured, distinguished members of the Marconi International Fellowship Council, that this award is for me a tremendous stimulant to pursue my work in this field and in the spirit of the fellowship's goal to apply communications technologies to the improvement of human life. Thank you.
Your Royal Highness, Excellencies, ladies and gentlemen, I have the pleasure to introduce to you Professor Yash Pal, recipient of the 6th Marconi International Fellowship. Professor Pal has been the engine behind the important application of satellite broadcasting to education in rural areas in his native country, India. At present, Professor Pal holds the key position of Secretary General of the United Nations Organization for the Peaceful Use of Outer Space. Professor Pal will now address us.
Your Royal Highness, Mrs. Braga, Excellencies, Dr. Pannenberg, distinguished guests, ladies and gentlemen. I'm overwhelmed as I look at not only at this beautiful hall, but also the people in front of me. To begin with, let me join all of you in congratulating my friend Arthur Clarke on receiving the Marconi Fellowship. I think I should also congratulate Mrs. Braga, the Marconi Fellowship Council, for selecting it. Arthur is one of those special people of this age that it is an honor for anybody to have his name in any way associated with him. So I am also proud. It would be an understatement to say that the present-day world would be rather different if the vision of Arthur Clarke had not been fulfilled, and I think Arthur would agree, probably much earlier than even he expected. Almost simultaneous and clearly synergetic developments in solid-state electronics, computer science, and space technology have now brought us to an era where we have the possibility of choosing from amongst various possible futures for the world. And I really mean choosing. There are many who ask that societies be fashioned so as to conform to the existing state of science and technology or to possible inevitable developments in science and technology, perhaps to proceed to an endless road to some sort of consumerist utopia. Even if it is probably for not all people on this earth. On the other hand, I've been struck by the fact that perhaps for the first time in history, we have available to us components and subsystems of technology which can be put together into so many different configurations, an infinity of configurations which we don't even yet realize, some of which actually might enhance the human condition tremendously, but others would not. There are choices to be made. We are finally on the brink of a new kind of freedom. Paradoxically, freedom even from technology itself. And we have the possibility, though only a possibility, of creating a world which would really deserve men like Guglielmo Marconi and Arthur C Clarke. I'm rather doubtful, though, that we are very fast proceeding in that direction. At this point, let me digress a bit, because a couple of years ago, the Marconi International Council pointed its finger at me. This is probably a good time to say a few words about my own version of the crime I'm supposed to have committed, and possibly also as to what I've been doing last 2 years, which might be relevant to the interest of Marconi Fellowship. As has been already mentioned, some years ago, I got pulled into the program of space applications in my country, particularly in connection with a direct television broadcast experiment to thousands of remote rural villages in India for the purposes of imparting information about health, hygiene, agriculture, family planning, and of course a great deal of entertainment, to villages where most people had never turned a knob before, most of which did not have electricity, very few had proper drinking water, where the schoolhouse consisted of a 3-meter by 3-meter room which used to cater to about 3 classes in a day, where the only scientific equipment in the schoolhouse was a blackboard, and sometimes even the chalks were not available. And here was a challenge then, a tremendous challenge which came my way because my distinguished predecessor, Dr. Sarabhai, passed away. And because while I was doing science, space science and astronomy, I was already interested in problems of education. We were thrilled by this opportunity through this magnificent new technology, which did not discriminate between the well-to-do urban areas and the rural areas spread far out, which abolished the tyranny of distance, which allowed you to go with systems and messages which would not slowly percolate far out into the country like ink dots on a blotting paper, but which can go there directly. We had, of course, a magnificent collaboration with NASA, who provided the satellite, especially for this purpose, which provided strong signals on the ground. But we decided that the ground infrastructure, the hardware, the development of the system must be done by us, because if the system has to have any viability for the future, we should learn to do it ourselves, do the inventing and building and repairing and maintaining ourselves. But much more than that was the problem: what kind of messages do you take to these places? What kind of wisdom do you have which is relevant to people so diverse, people speaking so many different languages, people having so many different problems with which you are not even in touch? We started going around the villages, scientists and engineers, and as a consequence, the place where we worked, which was a research and engineering center in technology, probably has become one of the first institutes where social science, communication, anthropology, and engineering and technology coexist, and where the engineers have actually walked through the villages, as we used to say, got cow dung on their feet. It's important because relevant technologies for special situations do need an intimate experience of reality. And we did find that even in terms of technical developments, what was possible to achieve was far bigger, much greater than anybody had hoped, largely because there was a new spirit which was firing even the engineers and scientists, because one was working against this tremendously large human background, and working in laboratories got to have a bigger meaning. And personally, for me, this has become a very live, important experience, because I do believe that in all the enterprises we take on, no matter what we work on, the larger backdrop, not only of rural life in India, which was a specific thing, but the larger backdrop of this beautiful, wonderful universe, our origins, where we came from, where we are going, the fact that this Earth, where is that beautiful picture out there, that blue picture of this little planet in this empty universe, we must keep focusing on that. Then we will realize our togetherness, our common past, and our common destiny. And if we work in this background, then possibly many of the things which we do at the moment, organizationally, technologically, will begin to have a greater meaning, will begin to have a greater direction, and possibly we will begin to fashion those systems out of the components which I mentioned earlier in a manner which will actually enhance the human condition. Specifically, in regard to this particular experiment, some lessons came which I do believe are valid and which have exercised my mind during the last 2 years and probably will continue to do later too. Technologically, it was quite a good success. Everything worked. System could be maintained even in the villages of India. People were capable of handling much more than one thought they would be. New initiatives emerged. Arthur called it the greatest communication experiment in history. And we keep on using these quotations whenever we want to refer to this experiment. It was, in a way, because it involved something like 6,000 expert man-years of work on the ground in India, besides the satellite. It involves 150 social scientists, 3,000 scientists and engineers around, maintenance, and it was a big effort. And it involved a social evaluation, program production, not only by broadcasting agency, but by educationists, by scientists, by engineers, and so on. As I said, technically it worked, but the social evaluation created a mixed picture. There were tremendous social gains in several areas. We were thrilled to see that this medium, which was no longer television, but it was an interloper, a stimulant in village, because in one village there was one set and 100 people came to watch every evening. This was just a stimulant, a catalyst, because it was an event where these 100 people interacted with each other in a certain ambiance, in a certain atmosphere. So it's not like ordinary television which you watch in your drawing room. It was a new event. It also filtered out the kind of population which would come to watch. There was a stratification automatically introduced. And possibly as a result of that, or because of our own bias in the messages, we found that illiterates gained more than the literates. And that's what we want. That women gain more than men. That people who were underprivileged, even in rural society, gain more than who were better off, because the better offs didn't come very often. And from that point of view, these were new learnings. We found that straightforward messages without sugarcoating were welcomed, actually, in spite of the advice of many communicators, and many things of this sort. But all the same, in spite of the fact that the programs were produced in 5 or 6 different studios set up in different parts of the country. Mind you, the area covered was something like 2,000 kilometers by 2,000 kilometers and only a few thousand sets. It ranged over a very large area. That in spite of making programs in many places, one thing which struck me at that time and remains a paradox of the great invention of satellite broadcasting and satellite communication. It allows us to increase the reach. Reach has become global. But the reach is global on the part of people who are close to the transmitter, who are close to the production. Large fraction of the people, even larger fraction, could become passive listeners. It is broadcast, it's not interaction, it's not communication. And as we all know, many things of real value, music, laughter, jokes, poetry, creation, occurs in close, intimate interactions. It arises through interaction. It doesn't arise only by somebody telling you a nice thing. So the challenge is, how do we bring about, how do we reconcile the long reach with the requirement that proper communication to lead to development must have interaction? It's being tried in many different ways in terms of having telephone hookups, people calling back, and so on. But somehow I believe that we have not yet found a way in which we can give the same quality to long-distance communication, the same degree of intimacy, the same possibility of exchanging nothings, the same neighborliness. We say that with space communication, neighborhoods have been redefined, distance has been abolished. Everybody is a neighbor of everybody else. It doesn't take any longer to talk from here to New York or to India than it does to talk to the next city. We can even see each other. Yes, we have become neighbors, But somehow something is missing because we have not yet become neighborly. Neighbors are people who can influence each other, whose actions influence each other. Yes, that has come about. But neighbors are people who also exchange salt and bread, who sit with each other when somebody is sick. Is it possible somehow to invent software, mechanisms of communication to be used with this fantastic new invention in such a way to give it this dimension of intimacy, that we might really begin to produce on this earth a rather thin environment, a thin veneer of intimacy which we associate with being neighbors. And this is what I hope for, and this is what I hope will be done, because I think in this area of communication science, in terms of how to properly exploit this fantastic thing which Marconi invented and which Clarke has worked on and many engineers have worked on, how do we really utilize the proper potential of this? We have not done enough work on this. We have not realized even the significance of this, and this is a challenge for the future. Recently, I was asked, somebody was writing a book, and I was asked to give a little piece in that, summarizing this, which is a little box which you put in there. I'll read that part to you. The electronic revolution, computers and space technology, have brought forth an era where lines of communication can be established in principle between all people on this earth. One can build visions where every human being would be an active agent in an interacting network of humanity. Education would be universal, ignorance would be wiped out, and the only remaining gaps between the rich and the poor, privileged and the not so privileged, powerful and the weak, would be those which arise even in a normal transactional relationship between equals. However, this is but a vision. Powerful technologies are more likely to be used for concentration of power than otherwise, unless there is a conscious effort to augment these with other subsidiary technological elements, social goals, and regulatory practices. The slogan, and I love that slogan, namely free flow of information, is often invoked to oppose social, ethical, or organizational constraints. But we know that all free flows are down potential gradients from highlands to lowlands, and can indeed flood the mass of people living down in the valleys, in spite of the best of benevolent intentions of some of the people residing on hilltops. Potential gradients exist both across countries and within countries. A poor developing country with very inadequate communication and educational infrastructure might be well advised to invest in a broadcast satellite. The simplest and the easiest option would be to generate all the messages in one central place with the help of a few clever communicators, and let rest of the millions soak up the showered wisdom. It's very cheap. And that's the danger you have exposed the world to, Arthur. It would also be very economical to fill up most of the broadcast time with sports events and reruns of I Love Lucy and Hollywood extravaganzas. It's happening because these programs are cheap to buy. All this may pacify the populace, may also lead to some information transfer, but will it lead to development? A system develops if its elements interact with each other to occasionally create a new configuration. True communication implies exchange, the involvement of two or more people, each giving to and taking from the other. Unless the input to the satellite is provided through many sources representing the real live experience of such interactions, the system will be a homogenizing venture at best and a centralizing and indoctrinating scheme at worst. So far, we've been rather conventional. in selecting from amongst the infinity of roadways for communication made possible by new communication technologies. There is too much emphasis on widening the already traveled highways, more intense communication, 30 television channels, 50 television channels, too few gateways and too many gatekeepers. We must find ways to provide autonomous access to bulk of humanity in the wilderness of long-distance communication by building some new pathways where none exist. Now, the beautiful thing, and that is what makes me a fantastic optimist, is that all this is possible now. It wasn't a while ago. It wasn't 20 years ago, it wasn't 30 years ago. We are at a period where it is possible, and it will be for the good of all. And we have to realize that there are many, many choices which can be made. Let us not just go on a road, even if it was laid by Arthur Clarke. He doesn't want you to go that way. And this is the real challenge where we have to take. Let me mention 3 or 4 projects very briefly as an indication, as a departure from what we are used to, and specifically at the moment tuned, let's say, towards the developing countries which live within the tropics. It's a question, it's one of the things which is being discussed. And I'm going to go away from the Clarke orbit. I'll talk of anti-Clarke orbits. Clarke orbit, that is satellite in a synchronous orbit, is a remarkable invention and has already changed the world. We can reach large parts of the world with this from 36,000 kilometers, and this will remain, and we will be using it for all time to come. Some time ago, a gentleman called, well, I'll mention him later, Ramani, looked at the possibility, at the figures needed for providing telephones in a country like India. And it's true of most countries. The cost of installation of a telephone, which you would need whether you have a satellite or not, because you need an exchange, a line to the exchange and telephone. This cost is of the order of $1,000, no matter where you do it. Now, it turns out to be 3 times the per capita income of an Indian per year. 3 years' income. And also of many people around the world. So we can talk of this beautiful revolution. Sure enough, broadcast is possible, but if you want these people to talk back to each other, and not only a few ministers or a few other people, they want to, influential people want to get together. Supposing you want to take it to people, how many years would it take? Does it mean that the interactive communication via satellite has absolutely no place for many of the needs which these countries require, which have? I think we have to change gears and look at what can be done. It wouldn't have been again possible even 10 years ago. But something is possible now, and I'd like to make a proposal, indeed repeat a proposal, which 2 gentlemen, Miller and Ramani, together have done, and in a technical journal, and not many serious telecommunication people don't want to look at it because they are so taken up by Clarke. Incidentally, I talked to Arthur last night. He was very excited about it. And that is, let's go back to satisfying some important, simple needs in these countries in the beginning, but which are technological needs of today, in addition to listening to broadcasts, which is happening anyway. India, for example, now has an operational television broadcast satellite as of 2 months ago. So the program which I was connected with is now operational. That will happen. But we want to be able to connect universities, educational institutions, banks, rural development agencies, people essentially who should be able to talk to each other, send messages and telexes all over, no matter where they are located in the country, in the forest, on the hills, away from lines, in villages, and we want to be able to get the answer within 2-3 hours. Now that's pretty quick, considering that a letter from India to United States now takes about 12 days, 14 days. It used to take 3 days about 20 years ago, because things are choking up. And the problem is the exchanges in these countries are also choking up. You may have a satellite, but the exchange is choked, and so people can't really get to the satellite so easily. So can we get away from this choking by a new system which is not a luxury system, but it caters in addition, in parallel to this, to very special needs? So what we do is we go back and have a low orbiting satellite at 1,000 to 2,000 kilometers, and we put it over the equator and let it circle the Earth over the equator, and it will do so every 2 hours. It'll just come around every 2 hours. Now this was not much used in early days, because you got a signal through for 15 minutes and the satellite was out of view. You sent a signal and it came back, but then it was out of view. But if you are talking of asynchronous, non-synchronous signals, now we have microprocessor technology. We have new memories which are developing, solid-state memories. We can put a memory, we can have clever software, computer technology. So I come and type out my message. It gets stored in this because I have done it in the afternoon when I feel like typing. The satellite comes 3 hours later, and the satellite comes, station 1 on longitude so and so. Come on, I have got this for you, and sends a burst which is received by this station. What have you got? For whom? And the station sends a burst, digital form. The satellite loads it on its back and travels, and it comes back within 2 hours to give you answers from anywhere in the world, within view. Just 2 hours. Who gets telexes within 2 hours delivered? And a very simple small transponder could in principle satisfy all the telegraph telex needs of present of a country like India, but it's much more than that. We have been talking of creating roadways between developing countries, news agency link-ups between developing countries. UNESCO has been seized of the questions of new information order. It is going to go all around. All the news agencies can be connected up. You can really build new rivers, new roadways, which will create new interaction, new dynamism, and these are connected then to the metropolitan countries by the synchronous satellites, and we have a real active interactive system going in the world. And this would be inexpensive. Powers will be low. So you'll need small stations like ordinary TV antennas, pointing there, doing anything. 4 or 5 watts of power there, 4 or 5 watts of power here, and it may be one idea to pursue seriously. Similarly, there is no reason for many of the countries. Incidentally, this you can do only if the satellite goes over the equator. If you put it over the poles, the Earth doesn't cooperate. The same Earth which gives Clarke his orbit by rotating, and he can put his satellite over the equator and manage to put it in such a way the Earth rotates and the satellite rotates along with this. The same thing creates another problem for this type of concept. If you put the satellite over the poles, when it comes around, the point under it has turned by 1,000 kilometers or 2,000 kilometers, depending on where you are. So you don't see it every 2 hours. You see it much less frequently. On the other hand, if you are on the equator, let the Earth turn a bit, it catches up, depending on which way it is going. So about 2 hours, it'll come back every 2 hours. So it's a postman which is very regular. Now this postman, this kind of thing, can do many other things. There are 3 or 4 other things you can do. Search and rescue satellites are being designed, they're being discussed. Now for northern parts of the world, Siberia, northern Canada and so on, of course we have to have polar satellites. But again you have to have several, because the Earth turns under. I'm in distress, I send a signal, satellite picks it up, sends it to a rescue station, they come and pick me up from the forest. But if we have to do search and rescue in the Amazons, in the islands of Indonesia or in the mid-Africa, those areas, the best thing is to have one satellite go around. If you have two, it'll come back every hour. All the messages you have will come through. Very simple, easier. So why should search and rescue missions for this part of the world be conducted through this sort of satellites? And similarly for navigation, and similarly for Earth observation, because you can do it many, many times. And I hope that some of these things would be pursued and would be discussed, and indeed I do plan to put it up to people so that we begin to invent specific things which appear to be simple, but they're not. They are complex, they are high technology, they are appropriate. Appropriate does not mean archaic medieval technology. Appropriate means it must be the latest technology, very sophisticated hardware, but they may not be grandiose or large looking. Finally, I get excited. I think, as you know, I have a fair amount of spillover from my preoccupations of that time into my present job as the Secretary General of the Second United Nations Conference on Space. And I find that the two really belong, and it has led me to the science, space, and communication, and now having gone around the world in many countries, at least has enabled me to develop a sort of personal kinship, not only with the rural areas of my own country, but with the whole of the world. And I think space and the distance-independent communication should develop this kind of belonging and kinship and lead to consequences, practical consequences. Space science, astronomy, and many practical demonstrations of the type we've been talking emphasize, on the one hand, our innate relatedness to each other and to all things around. They also underline the thought that there is only one distant future for man as a species, and that in the long range, a stratified and compartmentalized world is an impossible proposition. Even at a personal level, questions like who am I, where I came from, where am I going, which we all ask in our intimate personal moments, which are connected with some of the oldest questions which man has asked and probably led to all the spirituality, and maybe it was the origin of even religions of the world. Even at a personal level, somehow by now the rather well understood connections between our common atomic past and the future should give a feeling of connectedness and belonging in our present. It should have some impact on our goals and objectives and our relationships. I think we are so taken up and so overwhelmed with the success of our efforts to apply science and technology that the basic messages of that picture, for example, which could change directions, seems to be always submerged, are usually submerged. It does not seem to have any practical implications. So is it too much to hope that the world of future might come to be governed by a new ethic, which in this gathering one may call space or long-range communication ethic? Now that we have a possibility of establishing in principle an interactive communication between all peoples on this earth, one wonders whether it might not be possible to devise ways of doing this in a manner which would produce a universe of thin intimacy encompassing the whole world. Not all people one can talk to are friends, but people who we do not see or hear from are more often threatening than not. Perhaps one needs to match the newly acquired reach of communication with the even deeper understanding of communication process itself, so that one might be able to marry these two. And I think this will give real additional value